We've been discussing a lot on gas law. So far, we covered the Boyle's law, Charles' law, and the Avogadro's law. In this particular video, we'll focus on the combined gas law. The gas law of Boyle's looks like this. Charles look like this, and Avogadro's look like this. All of these three laws can be combined to give what is called the combined gas law that looks like this. The combined law actually has a glimpse of the Boyle's, Charles, and the Avogadro's law. Let's look a little more carefully of this particular equation. So you see Boyle's law, PV, PF, PV, PV, right? Now you see also the Charles law, VI over TI, VF over TF, and that's represented here as well. In the Avogadro's law, you see it over here. The volume is on top and the moles on the bottom. Now, this equation then could be utilized to do all of the problems that is related to gas law. Let's do a learning check. A sample of diborane gas, B2H6, a substance that bursts into flame when exposed in air, and that's what's happening over here on the right, has a pressure of 345 torr. I like to start off with just organizing everything together in the on the side over here with pressure, temperature, volume, and moles, whatever the information that they give you as I read. So let me go ahead and do that. So I've mentioned has a pressure. So my initial pressure is 345 torr. At temperature, which is my T initial, of negative 15 degrees Celsius, and a volume of 3.48 liters. If conditions are changed so that the temperature is 36 degrees, so this is 36 degrees now. So now my T final is 36 degrees Celsius. The pressure is 468 torr. What will be the volume of the sample? So it's looking for volume. You might wonder, where is the moles? Well, the number of the moles isn't here. That just means that you ignore them, or you just assume that there's a constant number of moles. Whether it's initial, final, the number of the moles will be the same. According to the combined gas law, it is PV over NT is equal to PV equal NT. And these are all initial here. Oh, and then on the right is all final. Initially, the number of the moles and the final number of the moles are the same. So we can take that out. So now I'm left with just these guys. Okay, now what I'm going to do is solve for V final. I want to solve for V final by itself. So let's go ahead and multiply T final both sides. If I multiply T final both sides, I get rid of the T final on the right. So I get PFVF here, but now I have a lot more going on the left-hand side. How about the PF? I'm going to divide PF both sides, meaning I'm going to place the PF on the bottom. So that will cancel this. So my V final is equal to TF PI VI all over PF TI. We can go ahead and plug a lot of the values in except for temperature. Why? Not temperature yet, because it must be in Kelvin. So let's go ahead and add 273.15 for both of these guys to get the Kelvin. So I want you to go ahead and calculate this out and come back. So here are the Kelvins. Okay, my temperature final is 3 309.15 Kelvin. My pressure is 468 torr. Why didn't I change that to atm? That's because the initial pressure and the final pressure is the same. Oop, I meant to say 345. And my initial volume is 3.48 liters. I'm going to divide all that by the final pressure. This is where the 468 torr goes. And my initial temperature, which is 258.15 Kelvin. So let's calculate this out to get our V final. So I have my 309.15 Kelvin times 345 times 3.48. And then I'm going to hit enter, divide that by, open up a parentheses, including both 468 times the 258.15. And I get 3.07 as my volume. I'm going to write that down on here, 3.07 liter. How did I know it was liter? Kelvins cancel, torrs cancel, and I'm only left with liters. So my liter, 3.07 liters. Let's do another learning check. Suppose we have a sample of ammonia gas with a volume of 7.0 milliliters at a pressure of 1.68 atm. Gas is compressed to a volume of 2.7 milliliters at a constant temperature. Calculate final pressure. So I want you to try this on your own and come back and check the key. And here is the key. I want to make a note of something here. You probably have seen that or read that there is no information about moles, and there is an information about temperature, but it says they're both constant. Having that there's no information about moles just says that it's constant. And same for temperature. That means that I can take out in the combined gas law the constant temperatures and also the number of the moles. Then I'm left with only PV is equal to PV. And that happens to be the Boyle's law. So you only really need to know the combined gas law to know all of the law, the Boyle's, Charles, and the Avogadro's law.